A proposition is a declarative statement that is either true or false. They are also called sentences or statements. Now let us take some simple propositions. When you talk about simple proposition, it will return you either true or false. If the statement returns true or false value, then it will be called as a simple proposition. Now if I ask you, is the earth is full of 3/4 of water? That is, 3/4 of the earth is full of water. If I say this statement, your answer would be either true or false. In this case, it is true. So this is a simple proposition. 10 plus 3 is equal to 31. This will return false. So this is also a simple proposition. New Delhi is the capital of India. This is true. So this is also a simple proposition. 16 is more than 20. It will return false. Therefore, this is also an example of simple proposition. Remember, all imperative or interrogative statements cannot give true or false answer. Therefore, they cannot be called a proposition. For example, where do you stay? Okay, if I ask you, where do you stay? Your answer would be different, my answer would be different. So it is not returning true or false. Therefore, it is not a proposition. Second one is, how long is the meeting will go on? Meeting may go on for 1 hour, half an hour, 2 hours. So it depends. So this is not returning true or false. Therefore, it is not a proposition. What is your name? Your name is different. My name is different. Therefore, it is not a proposition. Now, in this chapter, after going through the video, what are the probable questions you will face? Okay, you have to draw truth table, okay, for this expression, and you have to show that this is equal to this variable p. Then you have answer the following question. You have a proposition out here in p, you have a proposition here in q, and you have to answer these questions. And so lot many questions will be there in this format. Here a table will be given and it'll be told to tell key this is tautology or tautology, contradiction or contingency. That means you have to fill this form and you have to see this particular column, okay, what values you are getting. Depending on that, you have to say this is a tautology or a contradiction or a contingency, right? So friends, let us learn how to fill a truth table. Here in this table, you have two variables a and b, and these are the different expressions you have. This last expression, you have to see after solving this entire thing, you will come to know, seeing the last column, whether it is a tautology, contradiction or a contingency. But the most important thing right now is how to fill the table. Let us first of all know how many rows you're going to make, right? You have two variables, so 2 to the power n, 2 to the power 2 variables, that is equal to 4 rows, and one extra row I'll take for header, right? And how will you fill the columns? Here b column, that is the last variable, will be filled up with 1 0 1 0 1. Then this will be filled up with 2 zeros, 2 ones, and so on. Now in case of 8 rows for 3 variables, how will you fill? The last column will be filled with 0 1 0 1 0 1 0 1. Then double of 1 would be 2. 2 zeros, 2 ones, 2 zeros, 2 ones. Double of 2 is what? 4. 4 zeros, 4 ones. So this is how you fill a table, right? Now let us understand what is a compound proposition. If two or more simple sentences are joined with the help of some words like and or, then the resulting statement is called a compound statement. Here in A variable you have Asansol is an industrial belt, and in B you have it is in West Bengal, India. So A and B are propositional variables, and these two sentences are propositional values or constants. Now if I want to represent as this way, A reverse of V and B, it means what? A and B, which is Asansol is an industrial belt and it is in West Bengal, India. So this is how you represent different connectives. Let us know about more connectives. In propositional logic, generally we use 5 connectives. Disjunction, that is or, indicated by V or plus. Conjunction, that is and, indicated by reverse V or a dot. Negation, not, that is indicated by this symbol or this symbol. Implication, that is if then, or conditional is indicated with a right arrow. If and only if, that is biconditional, it is indicated by a double-headed arrow. Now this is OR connective. The OR operation of two propositions A and B can be written as A or B. Now this will return true if at least any of the proposition variable A or B is true. In simple sentence, it means if any value of A or B if true, that is 1, then in that case the answer would be true, that is 1. 0 and 0 will give you 0, false. None of the signal is what? On, that is 1. Here 0 or 1 will give you 1. 1 or 0 will give you 1. 1 and 1 obviously will give you 1. Remember that in the truth table you can represent value true with true, that is 1, and false with 0 also. And connective. The AND operation of two propositions A and B can be written as A and B. Now here you see the truth table. Now this is the thing that you have to see. When all the values are true, for A it is true, for B it is true, if you have C, if it is true, then only it will be true, and in other cases it would be false. 0 and 0 would be 0. 0 and 1 also will be 0. 1 and 0 also will be 0. 1 and 1, in this case only it will give you 1. Negation. It means, suppose if the variable's value is 0, if you say not A, that is 1. If A is 1, not A would be 0. Double negation, let us see. It is indicated this way. Let the variable be A. Suppose the value is 0. Negation of A would be 1. And if you again negate it, then 1 will turn to 0. Here also, if it is 1, not A would be 0. And if you negate this thing, not 0, that means 1. So this is double negation. Double negation gives you the original value. Implication, that is if then. In if then, you see this particular row. If A is true and if B is false, in that case only it is false, and in all other cases it is true. This is very important. Keep in mind, true, false, false in if then statement, that is implies statement. In all other cases it is true, but true, false would be false. And biconditional statement, if and only if. Okay, you just see, if and only if means when both the values are same, in that case it is true. 0, 0, it is here true. 1 and 1 same value, in that case it is true, and in all other cases it is false, that is 0. Now, what is a tautology? A tautology is a formula which is always true for every value of its propositional variables. Now let us check. This implies B is a tautology. Very interesting. Just have a look. We know how to fill the table. So I have done 0, 1, 0, 1, 0, 0, 1, 1. A implies B. I told you what? A implies B. When it is false, 1, true, false, false, and in all other cases it is 1. Now this one, A implies B, this is in bracket, and A, that means you have to check this and this column. And operator means when you have true in both the columns, so you have to check this and this. That means 1, 0, it will give you 0, 1, 0, it will give you 0, 0 and 1, it will give you 0, 1 and 1, it will give you 1, right? Now this entire thing implies B. You have to check this column and this column. 0, 0, it will give you 1, 0, 1, it will give you 1, 0 and 0, it will give you 1, 1 and 1, it will give you 1. Implies means true, false, false. In all other cases it is what? True. Therefore this is a tautology. Now we have to prove this is a contradiction. Contradiction means you will have all the values as false. You just fill the values, all the rules are given, just do it part wise. Take this one, okay, then you have negation of A, you do it separately, negation of B, this, then entire thing, this one, negation of A and negation of B is giving you what? This, and finally then you do what? This entire thing is giving you what? And you see the last column, if it is filled up with all zeros, then it is a contradiction. Same thing out here. If it is a mixture of zeros and ones, then it would be a contingency, right? So tautology means all ones, contradiction means the last column will be having all zeros, and contingency means it will have what? A mixture of zeros and ones. Now we will come to know about antecedent and consequent. A is equal to what? It is cloudy today. This is antecedent, right? And what is antecedent? Just have a look. If A implies B, if it is cloudy today, then you cannot go out. Hence, the first part of the condition, this one, is antecedent, and the part to the right is consequent. So this is antecedent, and this is consequent, right? Now we'll come to know about converse, inverse, and contrapositive. There are two propositions you will play. You have stored it in P, and in Q you will not go to the party. Then P implies Q would be, if you will play, then you will not go to the party. A P implies Q. When you have this kind of thing, you can find out the converse, inverse, and contrapositive. Converse would be, initially you had P implies Q. So if you bring Q this side and P that side, that turns converse. Q implies P. Inverse would be what? Take the original statement, P implies Q. So if you negate both of them, not P implies not Q, that would be inverse. And what about contrapositive? It would be, first of all, you first converse it. That is, P implies Q. Converse would be Q implies P. Then you negate them. Not Q implies not P. So that would be contrapositive. Remember, CCI or converse, inverse, and contrapositive is possible for if P implies Q, that is for if-then statement only. Thank you so much for watching this video. We'll be back soon with another interesting video. Till then, keep learning from E-SHIKSHA. Thank you so much.